Hi, here's your example 3.2. I know that on my paper right now, it says it's example 3.3, but it's actually 3.2 for you, okay? I've adjusted it so it's better for you. So again, if you watch the first example, you should know that there are 4 steps to PMI or proving something using principles of mathematical induction. Well, we're going to do the same 4 steps for this guy here, which says, prove that 1, 3, 5, when I add them together, which is the arithmetic series 2n minus 1, when I take the sum of that, it's actually equal to n squared, which is pretty amazing, okay? All right, so let's prove that it's true for all positive integers n. So again, what's the first step? Step 1 is to verify or the anchor, okay, anchor. So let's try this, okay? So n equals 1, which means one term, right? So we're going to say 1. Does it indeed equal 1 squared, the right-hand side? And it's true. Well, you know what, you guys? Let's try 2. Okay, let's try 2, which means it's 1 plus 3. Does that equal 2 squared, the right-hand side? It really does. Isn't this amazing, you guys? It's so cool, okay? I think it's so cool. You know what? If you don't believe me, let's try 3. Hell, why not, right? N equals 3? So it's 1 plus 3 plus 5, which we should get is 9. Wait a minute, is it equal to 3 squared? Yes, it is. Holy cow, okay? So this formula is magical. We're going to try to prove that this is true for any case. Even if I add one more, like one more domino, okay, or one more to this series, it's still going to be true. We're going to prove that, okay? All right, I'm going to block this guy off. We did the anchor. What's the next step? Next step is the second step, which is called the inductive. Step 2, inductive hypothesis. So we're going to make a hypothesis because we're going to do the inductive step later, right? Inductive hypothesis means this. Let's assume n equals k. Because remember, you guys, this guy that's given to you is p sub n, right? Let's let n equal k. Then what do we know? Then we know that p sub k has to equal 1 plus 3 plus 5 plus ... plus 2k minus 1, right? Plus, or equals k squared, okay? We're going to prove that this is true. But now we just let n equal k, okay? Okay, that's our inductive hypothesis. Now let's start the inductive process. Third step is your most important. It's the meat. It's like your body, right? It's like the body of your essay. Inductive step. Okay, inductive step goes like this. You have to add one more to your original series, which means it's 1 plus 3 plus 5 plus, right? Plus ... plus your original 2k minus 1. But we're going to add one more, right? We're going to add one more. What? How many more? Just one more. So k plus 1 minus 1. Rather than putting k, we're going to put k plus 1. So I add that. Okay? But remember, we're only working with the left-hand side, and then we're going to eventually get to the part where we naturally and organically, the right-hand side comes to play. So you know what we should do? We should make a goal right now. What is our goal? Let's write a goal here. Remember, our goal is basically this. Our right-hand side formula plus 1. We're going to eventually get to this. K, not k squared, but k squared, k plus 1 squared. Or if you want, you can write k plus 1 times k plus 1. Okay, or k squared plus 2k plus 1, whatever format it is. We're eventually, when we prove this, it's going to come to here. Let's see. Because if this is true, if this is a true, or this works for all positive integers, we should be able to prove it using PMI. Adding any more one by one to that series, it should still come out to be true. Let's try. Well, we already know that this guy is true because we've already proved it with the anchor. We already know that this is actually equal to p sub k. So what's p sub k? It's k squared. Do you guys see how that's p sub k? And p sub k, when you add it together, all becomes k squared. And then we have plus 2k plus 2 minus 1, which is plus 1. Okay? Do you guys see I just multiplied this in and then I simplified it. Okay, so what? Wait a second. So we have k squared plus 2k plus 1. What the factor? You guys, I mean, we could go ahead and factor this. Oh my gosh. Look, it's exactly our goal. Holy cow. Okay, so we've already proved it, you guys. We've already proved it. So let's do the last step, which is our fourth. conclusion. Very important. Ready? Therefore, by PMI, okay, we can conclude that Pn is true for all positive integer n. So I'm going to write this ugly Pn here. I'm going to erase it. Sorry, I'm at the bottom, so I can't really write. So it's P sub n is true for all positive integer n. And we did it using PMI. Okay, now what I want you guys to try is this. Now that we've tried, I showed you 1 and I showed you 2. See if you can mimic this process for this example that you see on your notes. It should be example 3.3 for you. Okay, try that and then watch the third video. Okay, all right, good luck.